Okay, hey you guys. So for the question of the day, you're using the molecular orbital diagram of O2, which is pictured above, to answer the following questions. So we can see the atomic orbital for oxygen is on either side, so that's in green, and then each oxygen brings 8 electrons, and so those are all put in. Down here, you guys, it is skipping the 1s electrons. So just a word of warning, sometimes you get an abbreviated diagram. So when we look at the bond order, because we're missing the 1s electrons, technically we're not using all the electrons. But when we think about those 1s, if we go past it, 2 of them are bonding, 2 of them are anti-bonding, so they cancel each other out anyway. So it is okay to just look at these valence electrons here. So our bond order is going to be 1/2 the bonding, and so we've got 2, 4, 6, 8 bonding, minus our anti-bonding, which are going to be 2, and then 3, 4. So 8 minus 4 is 4, 1/2 of 4 is 2. So our bond order is 2, which means that when O2 is bonded, it is a true double bond, which I would agree with. This is the correct structure. So that confirms our theory. And then the last question asked, is it diamagnetic or paramagnetic? So again, what I saw up here in these anti-bonding is that there's 2 lone electrons. So lone ones, they don't have a partner. So it's going to be paramagnetic, meaning there will be some magnetic character to O2.